Ted mistakenly wrote 2 to the power of m times the square root of 1 over 4096 as 2 times the m root of 1 over 4096. What is the sum of all real numbers, m, for which these two expressions have the same value? First step was to set them equal to each other, and I will immediately convert this to exponents, which a square root is exponent half. And this is 2 times 1 over 4096 to the exponent 1 over m. Okay, so off we go. Now the first thing we can do is combine these m's, divide both sides by 2, and when you do, you get 2m minus 1, like that. And then similarly, if you divide both sides by this expression, you would get 1 over 4096, and this would be 1 over m minus a half. So that's just based on exponent laws. Okay, so now obviously I'm going to have to convert this to a power of 2. So let's do that. I believe that's 2 to the power of 12. Yeah, so it's 1 over 2 to the power of 12. And this is all 1 over m minus 1 half. Okay, so I guess this would become 1 to the power of that, which is just 1, and then 2 to the 12th, all to the power of 1 over m minus 1 over a half. So that's 2 to the power of m minus 1. And then this obviously will become 1 over 2 to the power of 12 over m minus 6. Okay, keep on going here. And then cross multiply, and you get 2 to the power of m minus 1 times 2 to the power of 12 over m minus 6, and that all equals 1. And then finally, combine these exponents, so you add them, so it'll be, let's see here, m plus 12 over m minus 7, and that is equal to 1. Okay, so if that exponent, if 2 to the power of that exponent equals, sorry, this should be 6. If 2 to the power of that exponent is equal to 1, that means this exponent is 0. So that means m plus 12 over m minus 7 is equal to 0. So hopefully that makes sense. And now we just have this basic equation here. And probably it's a quadratic, maybe it factors. Multiply through by m, and we get m squared plus 12 minus 7m is equal to 0. And I think that factors, I think 3 and 4 should do it. Minus, minus. Yeah, okay, that works out really nice. So that means m is equal to 3 or 4. And what do they want? The sum of those values. So I guess 3 plus 4 is 7. And there you go. That's the answer, and that would be choice C. On Halloween, 31 children walk into the principal's office asking for candy. They can be classified into 3 types. Some always lie, some always tell the truth, and some alternate between lying and telling the truth. The alternators arbitrarily choose the first response, either a lie or the truth, but each subsequent statement has the opposite truth value from its predecessor. The principal asked everyone the same 3 questions in this order. Are you a truth teller? Are you an alternator? Are you a liar? And 22, 15, and 9 answered yes. How many pieces of candy and all did the principal give to those who always tell the truth? All right. So these responses we'll have to create into an equation. The truth tellers I will call T. The liars I'll call L, and the alternators I will call A. So the ones who always lie are these guys. The ones who always tell the truth are the T's, and the ones who alternate are A's. But then we've got 2 types. We have the alternators that start with a yes and then say no, and then we have the alternators that start with a no and then say yes, because we're not sure which lie they, or what answer they give first. Okay, so the 22, that can be made into an equation. 22 would basically be T plus L plus some of the alternators. We don't know which ones, right? Because are you a truth teller? If this person tells the truth, they would say yes, right? That's these guys. If they're liars, they're going to lie and say, yes, we're truth tellers. So that's these guys. And then the alternators, some of them, the reason I put some is because we don't know, are they saying yes first or are they saying no first? So that's why I put some A. Now the next equation would be equal to 15, and that's basically people who are asked, are they alternators? Now that, of course, some of the alternators would say yes to that. We don't know which ones are the ones that are saying yes first or no first. But then, of course, all the liars, because the liars are liars, but they're going to lie and say, oh yeah, we're alternators, even though they're not. And then the last one, are you a liar? That one is a 9. And that one, I'm not sure if we even need that one, so I'm just going to leave that blank for now. I think we're just going to work with these two equations. If you subtract them, you get 22 minus 15 on that side, and on the other side, you just get left with t. So t is basically equal to 7. So that means that 7 students always tell the truth. And that's basically what they wanted. So that's choice A for this question. Let triangle ABC be a scaling triangle, point P on BC, such that AP bisects angle BAC, and the line through B perpendicular to AP intersects the line A through BC at point D. Suppose BP is 2, BC is 3. What is AD? Okay, so first we have to draw this somewhat scaling triangle. Okay, and then we have to draw a line that's parallel, so like this, and then finally we have to draw a line that cuts through the angle BAC. So first we have to label this. Let's say this is BAC, like that, and then let's draw like this. So that is going to be P according to the question, and this is theta, and this is theta, and then this is parallel to this line. And then the line that through B that is perpendicular to AP. Okay, so perpendicular. So I guess like that. So this is a right angle. That intersects the line at D. So this is D right here, that guy. Okay, and then BP is 2. So this is 2 up here. PC is 3, and then off we go here. So let's see what we can do with this. First, let's label as many angles as we can. This angle in here I'll call alpha, and therefore this is a right angle also, right? These are all right angles, that whole thing. So that means this must also be alpha, since those two triangles are pretty much the same in terms of their angles. All right, and what else can we do here? Let's see here. ABX. Well, I'm gonna call this point X right here. This one right here. This point X. So ABX, that triangle, is pretty much the same as the other one. So I guess I have to label it. I'll call that point Y. So that's going to be triangle AYX, like that, right? Because it's side angle side. So, or it's all three angles, or they share a side also. Regardless, I mean, they're definitely similar. So because they're similar, AB, that side, is the same as AY. So I'm just going to label AB, let's call it A, and therefore AY is A, like that. Okay. And then I am going to need to label another one. From Y to C, I'll call that B, since I'm not sure what it is. And then we'll use something called the angle bisector theorem. And if you're not familiar with that, I'll just give you an example. Let's say you have a triangle, and then you have a bisector. This is theta, and this is theta. And this side is A, this side is B, and this is X, and this is Y. Angle bisector theorem states that A over B will be equal to X over Y. So applying that over here, this, with this being the theta, that would basically give me the following. That would mean that a over a plus b is the same as 2 over 3. Right. So now this will be 3a is equal to 2a plus 2b, and therefore a is equal to 2b. Okay, great. So AC, all the way from A to C, looks to me like it's a plus b, but since a is equal to 2b, that's going to be 3b. All right. Okay, so now we got to go back and look at this again. Let's see if we can get any more similar triangles. BCY, that angle, I'm going to call gamma, let's say. And I think that's the same as YAC. Let me think about this for a second. Gamma, YAD, right? Because these are parallel lines, right? This was parallel to that one. So this is also going to be gamma. So BCY, that angle, is the same as angle angle YAD. Yeah, because of the parallel lines property. And then similarly, CBY, this angle in here, which I can just call theta 2, whatever. So angle CBY is going to be the same as this guy YDA, this one over here, by the same sort of parallel line property, YDA. Okay, so that helps because that makes a similar triangle situation between the triangles AYD, and the triangle BYC. Yeah, CBY. Because they will essentially have the same angles. Okay, so since that is the case, we can now create another property that AY over CY is the same as AD over BC, right? Because AY is going to be over the CY, which is the equivalent, and the other triangle is the same as AD, which is the gamma theta 2, and BC is also the gamma theta 2 side. Okay, got it. So AY, now we can substitute. AY is equal to A, but A is equal to 2B, so put that in there. CY is B, and then we have AD. AD, I think we don't know yet. That's what we're trying to figure out. Okay, got it. And then BC is 5. That's according to the question. Okay, so this basically leads to the B's cancel, and that just becomes 10 is equal to AD. And there you go. So we've got C as the correct answer. How many ways are there to split the integers 1 through 14 into 7 pairs such that each pair, the greatest number, is at least 2 times the lesser number? All right, so we want to create a situation where we have pairs like AB, and one such example is 2, 5. So according to the question, the greater number, which in this case is 5, is at least 2 times the lesser number. The lesser number is 2, 2 times that is 4, and 5 is indeed greater than 2 times that 2. So that's just one example. So we want a situation where B is at least 2 times greater. So B is greater than 2A. Greater than or equal to, right? Because it could be equal, I believe. Okay, so let's work through this. Let's list all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so let's talk about this now. Okay, so when I'm going to start with this half, because we've got to find a way to place the big numbers first, and then all the other numbers sort of match, I guess they pair up. So let's start with the 8 first. So the 8, that can pair with pretty much anything from 1 to 4, right? Because the number I can't put a 5 because then 8 wouldn't pair with it. It wouldn't hold this property. But it can pair with anywhere from 1 to 4. So we've got, in terms of choices, we've got 4 choices for the 8. Yeah. Because it couldn't pair with any of the bigger ones because then the property wouldn't hold true. This one right here. All right, so let's keep going. The 9 can pair with also anything from 1 to 4. And therefore, we have 4 choices there. But we've already used one choice here, whatever we choose. So it's going to be 4 minus 1, which is 3. All right. 10 can pair with anything from 1 to 5. But we've already chosen one number here to pair with the 8 and one number here to pair with the 9. So those two numbers are gone. So we have to subtract from the first 4, 2, and then we have to add 1 for the 5, right? Because the first 4 numbers, 1 through 4, one of those has already been chosen to pair with the 8, and one of them has already chosen to pair with the 9. So from the first 4 numbers, we've already taken away 2, 1 to pair with the 8, 1 to pair with the 9, and then we've added the number 5 as a new number that can pair with the 10. So that's why this plus 1. So 4 minus 2 plus 1, and that's 3. Okay? All right, so this is the system we have to go through here. Okay, now we're up to 11. 11 can pair with, very similar, I think, 1 to 5. And then now, of the 1 to 5 numbers, we've already chosen one number for 8, one number to pair with 9, and one number to pair with 10. So those 3 choices are gone. So from the 5 numbers here, we have already chosen 3, so that leaves only 2 left. You got it? And then for 12, 12 can pair with anything from 1 to 5. Right? It can pair with anything from 1 to 6, but I just want to write 1 to 5, make it less confusing. And from the numbers 1 through 5, which is 5 numbers, we've already chosen 4 to pair with the 8, the 9, the 10, and the 11. But then we have to add the 6, right? Because then it can also pair with the 6, so that's what this plus 1 is for. So that basically gives me 2 possible choices for the 12. Now the 13 can pair. We actually only have one choice left at this point. Yeah. So we only have one choice left because 1, 2, 3, 4, 5 numbers have already been chosen. And from this group, so there's only 2 choices left. So one goes for the 13 and one goes for the 14. Yeah. And that's it. I think that's it. So multiplying, we have 4 times 3 times 3 times 2 times 2 times 1 times 1. So 4 times 3 times 3 times 2 times 2. Well, the ones you don't really need. Well, you can put them in there if you want. And this all would be 144. So 144, which is choice E. There you go. Quadrilateral ABCD with side lengths AB7, BC24, and CD20, DA15 is inscribed inside a circle. The area interior to the circle but exterior to the quadrilateral can be written in the form A pi minus B over C. What is A plus B plus C? So we've got a circle, and then we've got this quadrilateral, and this is 7, let's say. This is 15. This is 20, and this is 24. So just a basic drawing to illustrate. So this is 7, 15, 20, and 24. And then let's label this accordingly. A, B, C, and D. Okay. So what they are saying is that the area interior to the circle but exterior to the quadrilateral. Interior to the circle, exterior to the quadrilateral. So I'm assuming that is, I'm assuming this part here. Yeah, pretty confident about that. Okay, and they're saying that that area can be written in the form a pi minus b over c, and then eventually they want you to figure out a plus b plus c, basically add those coefficients. Okay, so how do I do this? All right, well, obviously I need to figure out the area of that quadrilateral. So the first thing I'm going to do is I'm going to draw a line from A to C like that, and then let's see here. I think I've figured this out. I just noticed that these are actually right angles, because these are those. So because these are right angles, that makes it easier for us to figure out the area. So the area of that region would basically be the area of the full circle minus 2 of these triangles. So it's 1/2 base times height, which would be 15 times 20, minus 1/2 base times height, which would be 7 times 24. So that really helps that those are right angles. It makes it easier for us to figure out the area. Now this is a pi plus b over c. We're going to have to figure out the radius, but let me just calculate this first. This is going to be minus 150, and this will be 12 times 7, which is minus 84. So this will be pi r squared minus 234. Okay, we still need to figure out the radius, and that's where this formula comes in. Some of you know this, some of you don't. If you got a triangle and it's inside a circle, and then you put the center of that circle and you draw the radii to the edges, so that's going to be r, r, and r, since that was the center. And these sides are A, B, and C, the side lengths of the triangle. There's a formula, and that formula is that the radius is equal to A times B times C over 4 times the area of the triangle. So in this case, that triangle is ABC. So let's use that formula up here. Let's see if we can do that actually. So in this one, we have 2 triangles we could choose from. Either one is fine. For example, if we put the center here and say this is the radius, this is the radius, this is the radius, we can use either one. So I'll just use the 724 one. So the 724 one, that one, because it's a Pythagorean relationship, this is 724 and this is 25. This will be my A, B, and C. So this will be 7 times 24 times 25 all over 4 times the area of that would be 1/2 base times height, which is 7 times 24. So that basically makes this 25 over 2, I believe, right? Which is 12.5. Okay, great. So I'll pull that 12.5 in there. And I think that will be that'll be all you need. So that's going to be 156.25 pi minus 234. And then we have to get it into this form, right? This form. So obviously it's a fraction, so multiply top and bottom by 4. So that's going to give me 625 pi minus 936 over 4. And I think that's how you get it into this form. So therefore A is 625, B is 936, and my C is 4. And therefore A plus B plus C would be 625 plus 936 plus 4, which is equal to 1565. And 1565 is choice D. The roots of the polynomial 10x cubed minus 39x squared plus 29x minus 6 are the height, length, and width of a rectangular box. A new rectangular box is formed by lengthening each edge of the original box by 2 units. What is the volume of the new box? All right, so we've got this box here, and it has the dimensions that are the roots. So I'll just call it R1, R2, and R3. And our equation is 10x cubed minus 39x squared plus 29x minus 6. And I'm just going to write it as ax cubed plus bx squared plus cx plus d. And we will use our famous Vieta's formula, which you guys may remember or may not. If you don't remember, not a problem, I'll go through it. So Vieta's formula says that the sum of the roots will be equal to the following. It'll be R1 plus R2 plus R3 is equal to minus B over A, where B and A are the coefficients of that kind of an equation. The products of the roots, so that would basically be represented by R1 times R2 times R3. That is minus D over A. And finally, the sum of the products, so what that means is basically R1 times R2 plus R1 times R3 plus R2 times R3. That is equivalent to C over A. And therefore, we can get this using this equation, since we have an equation with coefficients. So minus B over A looks to me like 39 over 10. Minus D over A is 6 over 10. And C over A is 29 over 10. Okay, great. So what they want really is they want the volume of the box, which in this case would be just R1 times R2 times R3, right? But they say that each of these is going to be extended by 2 units. So what that means, it's really R1 plus 2 times R2 plus 2 plus times R3 plus 2. That is basically the volume of, well, this new box that they've created. Okay, so that's what we're going to do. We have to figure this out, and we're obviously going to use this, and this, perhaps all 3, I don't know. But that's going to be helpful since we have numerical values for those guys. All right, so let's expand this all out, and let me do this. So we've got, R1, R2 plus 2R1 plus 2R2 plus 4 times R3 plus 2. And then this becomes, I'm going to need a little bit more space here, R1, R2, R3 plus 2R1, R2 plus 2R1, R3 plus 4R1 plus 2R2, R3 plus 4R2 plus 4R3 plus 8. Okay, so now we get to use these guys. Okay, so this one here is this. So that's 6 over 10. Great. This, and this is similar to this. It's just 2 times that. So it'll be 2 times, did I make a mistake here? I don't think so. 2 times 29 over 10. Yeah, 2 times 29 over 10. So that takes care of this guy, and this guy. And then this, and this is very similar to that. It's just 4 times that. So it's 4 times 39 over 10. And then don't forget about that plus 8. So 6 over 10 plus 2 times 29 over 10 plus 4 times 39 over 10 plus 8. And when you crunch out all these numbers, you actually get a nice number 30. And that is choice D. Problem 17. How many 3-digit positive integers ABC are there whose non-zero digits a, b, and c satisfy 0.abc repeat is equal to 1/3 times 0.a repeat plus 0.b repeat plus 0.c repeat? Okay, so the first thing is I want to illustrate. Let's say I have something like 0.237. What is this in terms of a fraction? It's 237 over 999. and that is if this repeats like that. So generally speaking, that's basically how it works. So just in case you're wondering how you would write it as a fraction. So similarly, if you have 0.A, B, C repeat, that's basically A, B, C over 999. Got it? And then since they've given us this equation, the right side would basically be, this time it's only 1. So if you have, let's say, like 0.5 repeat, it's 5 over 9. I think some of you probably even remember that. So that would basically be A over 9 plus B over 9 plus C over 9. So a little bit nicer if you write it in a fraction. Now, this ABC, I'm going to write it in terms of what it is as a value, right? It's 100A plus 10B plus C. Because 237 is 2 times 100 plus 3 times 10 plus 7, right? That's basically what I did. I just expanded it out. And then cross multiply the 999, and this would basically be a 333, I think. And then we have A over 9 plus B over 9 plus C over 9, like that. All right, so now let's work with this, see if we can get anything. Let's see here. This will basically, if we divide 333 by 9, if you multiply, by 9, I think it gives 37. So this is 37A plus 37B plus 37C. And then this side didn't change. And then let's put everything on one side and see what we get. Or let's see what if I combine it, it'll be 27B and then 36C. And this will be 63A. Can I divide by something? I can divide through by 9. So that'll be 7A plus 3B plus 4C. Okay. So we've narrowed it down to this. So any ABC combination that satisfies that equation is going to be our solution to this problem. Okay. So let's make a little list here. A, B, and C. And then our 3-digit integer, our 3-digit number. So the first thing, just by inspection, I noticed that 111 works. So our 3-digit number obviously is 111. And they want to know how many of these guys can you get. Okay. And then I think you can also get 222, 333, and then so on, all the way down to 999. So all of those guys will work. So all the way down to 999. So this gives me 9 numbers. But I think I can get a few more. I noticed that with this guy here, with the 3B plus 4C component of that equation, if the B goes up by a factor of 4, then the C would have to go down by a factor of 3, just based on the way that is written. Or if the B goes down by a factor of 4, the C would go up by a factor of 3. And very similarly, if the B goes up by a factor of 3, the C goes down by a factor of 4. If the B goes down by a factor of 3, the C can go up by a factor of 4. So based on that, I think I can get 4 more. 4 more with sort of the 555 as my starting point. So if I go up by 4 with the 5 with this guy for B, I'll have a 9. And then that means I got to go down by 3 for the C. So I've got to go down to 2. And then if I plug those in and solve for A using that equation, I'll get a 5. So 592 will work. And then similarly, you can do the same thing with these 3 guys. And you'll get 518, 481, and 629. So 518, 481, and 629. So this gives me another 4. So 9 up here, 4 here. That's a total of 13. So 13 solutions, and therefore that would be choice D. Let tk be the transformation of the coordinate plane that the first rotates the plane k degrees counterclockwise around the origin and then reflects the plane across the y-axis. What is the least positive integer n such that performing the sequence of transformations t1 through tn returns the point 1, 0 back to itself? All right, now we need to figure out what is happening in this question. So let me just explain it with a little diagram. So let's say we start at 1, 0. Let's just use that point, might as well. And we are going to transform this somewhere. I don't know where, so let's just put it there. And we just kind of moved it from here to here by a certain number of degrees, let's just say theta. Then they're saying they're going to do this transformation. And what the transformation is it's called tk. And the first part of that is that you rotate it k degrees. So you're going to rotate it another k degrees, so this way. So from this point right here to this point right here. So for example, if it was t3, it would be 3 degrees. If it was t7, it would be 7 degrees, like that. And then the next part is that you reflect it across the y-axis. So if this is the y-axis, obviously, it would be reflected like a mirror image to that side. So it would end up here. So this is now your new point. Okay, so that's basically what it's saying. So I'm going to write it in terms of r theta, where this is like, since they're giving us 1, 0, I'm going to use sort of a unit circle situation. And theta is sort of representing the how many degrees it's rotating. And r is sort of the amount of distance, I guess, of this part. Okay, so the first move of this is a counterclockwise move by k degrees. So that would basically take it from theta to theta plus k. That's this part of that question. And then the next one is a reflex across the y-axis, right? So that would then make this go, if it was just r theta, it would basically be r 180 minus theta, if you're just doing that. But we are doing both this and this. So if we're doing both, we have to combine them. So if you combine them, that means that tk basically is a situation of r, and then you have to combine these. So it would be r and then 180 minus theta plus k. Right? Because first you are doing this guy right here, and then you'd have to subtract 180 minus whatever. So a better way of writing it is theta, r theta plus k would basically be r of 180 minus this theta plus k. Like that, which is exactly what I wrote here. And this simplifies to r 180 minus theta minus k. And that's your tk. You got it? So let's extrapolate this now, because we have to do this numerous times. So our initial r is 1, 0. Our initial point, whatever. And then we have our t1. So t1 is when k is 1, right? So that means 1, 0 would then go to if you use this formula up here, right here, it would go to 180 minus theta, which is in this case is 0, minus k, which is 1. So 180 minus 1, which is 179. Got it? So now let's do this again. K equals 2 this time. Now we have to do T2. T2 is you're taking 179, and then you're taking it to here. So it would be 180 minus theta, which in this case is 179, minus k, which in this case is 2. So this gives me 1 and minus 1, right? Yeah. Okay, let's keep it going. K3, this is T3 this time. Now we have 1, negative 1, and this would basically be 1, 180, minus 1, minus 3. So that looks like 181 minus 3, so 178. Okay, and then you just keep going here. I'll just do one more. K4 is this 178. So this is going to 180 minus 178 minus 4. And that looks to me like minus 2. So 1 minus 2. And if you extrapolate this, extrapolating, you basically get the following. That when you have a even value for this guy, for k, it becomes 1 minus n, like that. And you can verify that for these guys. And if it's an odd 2k minus 1, that kind of story, it becomes 180 minus k. So for example, when 2k minus 1 is 3, that meant that k was 2, and that's why we got 178. Okay? So what we want basically is this to be equal to 0, because we want 1, 0 to eventually go back down to 1, 0 again. So we want 180 minus k to be 0. That means we want k to be 180. If we want k to be 180, then that means that this guy would therefore be 2 times 180 minus 1, which is 359. So on T359, the 1, 0 would eventually go back to 1, 0 again. So that is 359, makes it choice A. Problem 19. Define ln as the least common multiple of all the integers from 1 to n inclusive. There is a unique integer h such that 1 over 1 plus 1 over 2 all the way up to 1 over 17 is equal to h over L17. What is the remainder when h is divided by 17? Well, now we have ln is the LCM of 1, 2, 3, all the way up till n. And we are given that 1 over 1 plus 1 over 2 plus 1 over 3 all the way till 1 over 17 is equal to this h over L17. And what they want you to figure out is what is the value of h divided by 17. So this is what we are trying to figure out. What is the remainder? Remainder when we do that. Okay. So let's figure this out now. LCM of all of these guys, but we need to figure out all of those numbers in their prime factorization. So that's how you figure out the LCM. So I'm going to write them all out. 1, 2, 3, 2 to the power of 2, 5 to the power of 1, 2 to the power of 1, 3 to the power of 1, 7 to the power of 1, 2 to the power of 3, that's 8. 3 to the power of 2, that's 9. 2 times 5, both to the power of 1, that's 10. 11, which is prime. 2 to the power of 2 times 3, 13. 14, which is 2 times 7. 15, which is 3 times 5. 16, which is 2 to the power of 4. 17, which is just 17. And I think that is it. Right? Yeah, because we want L17. So this is not going to be a problem. L17, remember, when you're taking least common multiple, think biggest. So I've got to take the biggest of every prime factor. So 1 is not prime, so I just start with 2. The biggest of 2 is 2 to the power of 4 right here. So that's part of my LCM. The next one is 3. The biggest power of 3, I believe, is 2, which is right here. The biggest power of the next prime is 5 to the power of 1. The next prime is 7. And I don't think there's anything greater than 7 to the power of 1. Next one is 11. Again, I think 11 to the power of 1 is the greatest. 13 to the power of 1 is the greatest. 17 to the power of 1 is the greatest. So that's pretty much it. That's L17, according to their definition. Okay. All right. I think we have everything we need, concentrating on this equation. So let's do that. So now we've got 1 over 1 and we got to write this whole thing out. I'm going to actually write it all out because it should help. So we have 1 plus 1 over 2, all that. And there you go. That's pretty much the left side of this equation up here. And then we have this equals h over L17. Well, this is L17. So that's going to be over here multiplied by this 2 to the power of 4, 3 to the power of 2, 5 times 7 times 11 times 13 times 17, and that is equal to h. Got it? Nothing tricky. It's just basically, exactly what they told me. Now, the only thing is I'm going to put this 17 back here because this is a very important thing that I'm interested in. And then everything else I can just work with. So now I have to basically take this guy and multiply it by each of these. And we'll get, pretty much our answer. Right? So we basically have to just crunch out these numbers. Now we want a remainder. So what that means is that what is the remainder? What is the value of that when all of this is crunched out? Now this whole thing here, this whole thing right here, right, I will call A. So what we're doing is essentially multiplying A by this guy right here. So that's pretty much all we're doing. So when we do that, you'll notice that when we do it for the first one, it becomes an integer. And when we do it for the second one, it'll divide by 2, so it'll still be an integer. If you do the third one, there's a 3 in here, so it'll still be an integer. And it's the same holds true for every single one except the last one. Except the last one. Because there's no 17 in here. You notice? So that is the only one that will give us a value that's not an integer. So when we take this and divide by 17, that is going to give us a remainder, basically. And what it does is it gives us, first of all, this is 720 divided by 17, and that's h over 17. And remember, I put the 17 down here. And this is 42395 with a remainder of 5 when you divide by 17. And that's pretty much what they wanted you to figure out. So it's a very good question, actually, if you take this step by step and don't get too intimidated by it. So 5 is the answer, and that would be choice C. A 4-term sequence is formed by adding each term of a 4-term arithmetic sequence of positive integers to the corresponding term of a 4-term geometric sequence of positive integers. The first 3 terms of the resulting 4-term sequence are 50, 7, 60, and 91. What is the 4th term of this sequence? So first we have a arithmetic sequence, which is of the form a plus d, a plus 2d, a plus 3d, like that. Then we have a geometric sequence, b, br, br squared, br to the power of 3. And each of these has 4 terms. That's why I wrote 4 terms. And they are telling me that when you combine these, somehow, you get these numbers. So the first combination is the first terms of each. So when you take this guy and this guy, so A plus B, and that is 57. The next combination is when you take the second terms. So I guess you take this one and this one. So A plus D plus BR, and that they're saying is 60. And then the third combination is when you take this one and this one. So that would mean that's A plus 2D plus BR squared, and that's 91. And what do they want? What is the fourth term of this sequence? So according to the same philosophy, A plus 3D plus BR cubed, and that is what they want. That is what we are interested in trying to figure out in this question. Okay, so I guess we first need to figure out the numerical values of A, B, R, and D. Okay, I think that's possible. The only thing, it sounds like that we were one short because we have three equations. Well, we need to figure out the values for 4, and usually you need the same number of equations as the number of variables, but I guess we can somehow try to figure this out. Okay, so here we go. Let me just label these now. 1, equation 2, equation 3, and then eventually equation 4. Okay, so let's do some algebra. Equation 2 minus equation 1, that will give me D plus BR minus B is equal to 3. Equation 3 minus equation 2, that's going to give me D plus BR squared minus BR is 31. Now, okay, so where do I go from here? Let's call this equation 4. Let's call this equation 5 because I think I can work with those two. 5 minus 4, that's going to help, I think. That's going to give me, over on this side, it's going to give me 28. But on this side, it'll give me BR R minus 1 minus BR minus 1 like that. Yeah, because the D's cancel. Yeah. Okay, and then this will basically be BR minus 1 times R minus 1. Yeah. Okay, that's good. And therefore, we've got a situation where we've got this B times R minus 1 squared is equal to 28. Okay, so I guess I have to now make a table and that whole big long song and dance. Yeah, because I've got two variables now, and I only have one equation, so I've got to figure this out manually. Okay, so do they give us any restrictions here? Do they tell us anything? Positive integers is the only thing they're saying. Okay, well, okay, that's a good, at least that's good. Now, in a geometric sequence, these R's, they have to be greater than 1. And then we are told that they're positive integers. So that means the smallest possible value of R could be 2. Okay. So if that's the case, if I put that in here, I'm going to get B equals 28. If I do 3, I will get 7. And then if I do 4, I don't think I will get any integer values after that. Yeah. I think that pretty much exhausts my integer values. So those are the only two values I can work with, because 5 won't give me an integer value, neither will 6, and neither will 7, so on. So what are my other ones? I have to figure out A, B, D, and R, right? So I've got to expand this table here. I got B and R, so I've got to put an A here and a D here. So using any of these equations, really, if I plug in the value for B equals 28 and R equals 2, and I solve, I will get 29 and 25. And for this guy, 7 and 3, I'll get A equals to 50, and, sorry, this is negative 11. Okay. All right, so let's see what happens here. First, let's start with the first one. If this is what the numbers are, my sequences, my arithmetic sequence would be 29 4, negative 21, and negative 46. Okay, that doesn't work because everything has to be positive. So that's no good. So I guess this is no good. So let's try this one. If I use those numbers, my arithmetic sequence becomes 50, 39, 28, and 17. Okay, that's good. Those are all positive integers. Now let's move forward here. What happens there? That's going to be 7, 21, 63, and 89. Correct? Yeah. Yeah. So that's good. Or hold on one second. Sorry, 189. Yeah. Okay, so that's also positive integer. So that means this is the one. Okay, perfect. Okay, so now I can go back and solve for this using these numbers right here. So A is 50. 3 times D is 7. D is negative 11. Got to make sure I put in the right numbers. And then B is 7. And R in this case is 3. And it's to the power of 3. And when you crunch out these numbers, you get 206. 206 is the answer, and that would be choice E.